Friends, today you are going to learn depth sorting algorithm, and it is another type of visible face surface detection method. And about the depth sorting method, it is a combination of both object space method and image space method. That is, it uses our sorting method uses both object space method and image space method. And the two basic operation of depth sorting method, or two basic functions of depth sorting method, are: first one is surfaces are sorted with decreasing depth, and the second one is that surfaces are scan converted in order starting with the surface of greatest depth. That is, the surface that having the greatest depth is scan converted first. And this method is also called painter's algorithm. That is, when creating an oil painting, an artist first paints the background colors, then he paints the most distant objects, then nearer objects, and so on. At the final step, for the nearer objects are painted on the canvas over the background. Okay, and as each layer is of paint covers up the previous layer. Similarly, we sort surfaces according to their distance from the view plane. That is, the intensity value of the furthest surface are then entered into the refresh buffer, taking each succeeding surfaces in turn, replacing the intensity of the previously processed surfaces. And here in this algorithm, we are making an assumption that we are viewing in the negative Z direction. That is, the viewer is sitting in the positive Z direction, viewing negative Z direction. And we are using a term depth overlap in this algorithm. It means overlap in the Z value. When there is a depth overlap, we need to check four cases. The first case is that the boundary rectangles in the xy plane for the two surfaces do not overlap. When there is a overlap in z direction, we have to check for the overlap in x and y directions. Next one is that surface S is completely behind the overlapping surface S dash relative to the viewing position. Next is third one is that the overlapping surface S dash is completely in front of the surface S relative to the viewing position. And the fourth one is the projection of two surfaces onto the view plane do not overlap. And we perform these tests in the order listed and proceeded to the next overlapping surface as soon as we find one of the tests is true. If all overlapping surfaces pass at least one of these tests, none of them is behind S. So no reordering is needed. When there is a depth overlap, we need to move to test 1, and if test 1 fails, move to test 2, and if test 2 fails, we move on to test 3, and if test 3 also fails, we will go on to test 4, and if test 4 also fails, we need to reorder the surface. That is, we need to change the order of scan conversion. That is, S dash is scan converted first, then S is scan converted. And our first case is, so when there is a depth overlap, we will go to our first case, that is test case 1. And if the test case 1 fails, if there is an overlap in x and y axis. Okay, that means this figure shows two surfaces S and S dash that does not have depth overlap. That is, no reordering is needed. We can first scan convert S and then scan convert S dash. But even when there is a depth overlap, we will move on to our test case 2 and check the overlap in the x direction and y direction. If we find an overlap in the x and y direction, that means x or y direction, that means test 1 fails. If the test 1 is failed, we can scan convert S and then scan convert the surface S dash. Test 2 and 3 checks whether one surface is completely behind the another surface. That is, whether S is behind S dash or whether S dash is behind S. And we know that when we put SYZ a particular plane, a particular coordinate in the Cartesian plane on the plane equation ax plus by plus cz plus d is equal to 0, and if we get the value equal to 0, the point is on the plane. If the value is less than 0, it is inside the plane, and is greater than 0, it is outside the plane. So we use this method in test case 2 and 3 to find which surface is behind than another other surface. And our test case 3 is that for the test case 3 for the test case 2, we will the points of S should be substituted in the plane equation of S dash, that is, and after substituting, if all the points in the plane equation got the value less than 0, it means that all points of S is inside, that is, S is completely behind S dash from the viewing position. And if the value is greater than 0, it means that all points of S is outside and S dash is completely in front of S. Okay, S dash is in front of S according to the viewing position. And the test case 2 fails. Here the test case 2 fails because S dash is completely in front of S and S is not completely behind S dash. A part of S is behind S dash only. So we will move on to the test case 4, and in the test case 4 we are using the projection in the view plane. And the first figure shows the test case 4 do not fails because there is no overlap. So S is scan converted first and then S dash is scan converted. If in this case, in the second figure, the test case 2 also fails. So we have to test case 4 fails as the projection of two surfaces onto the view plane overlaps. So we need to reorder the surfaces because all the test cases fail. We need to reorder the surfaces. That is, S dash is scan converted first and then S is scan converted.